Welcome to this explainer. You know, there's a truly fascinating mystery right now at the absolute cutting edge of technology. Have you ever wondered why the most advanced AI systems on the planet, the ones that can literally write poetry, code complex software, and pass the bar exam, can completely fail at toddler-level logic? Well, today we're unpacking a brilliant research paper titled Learn No to Say Yes Better. And honestly, it is going to completely change how you think about AI and language.
Let's kick things off by asking a pretty simple question. Why does cutting-edge AI seem to completely overlook negative words? Words like not or without. If you tell a person, hey, don't think of a pink elephant, they might struggle a bit, but they know exactly what you mean. AI, on the other hand, it seems to literally skip right over the negation.
Just look at these hilarious real-world failures from state-of-the-art generators like DALL-E and Midjourney. When you ask for a dog without ears, what do you get? A dog with giant floppy ears. Ask for a car without tires, and the AI proudly draws a car with perfectly round tires resting right there on the ground. It's almost as if the AI is eagerly giving us exactly what we told it not to.
So the culprits here are what we call vision language models, or VLMs for short. Basically, these are the foundational AI systems that connect text descriptions to visual images. But here's the catch. Right now, they act a lot like overly eager keyword search engines. When they see a prompt like a dog without ears, their digital eyes light up at dog and ears, and they completely 100% ignore the word without. What these models are fundamentally lacking is true compositional understanding. That's just a fancy way of saying they need the ability to grasp how individual concepts and relations actually build a whole scene. Think of it this way. Human language isn't just a loose bag of vocabulary words dumped onto a table. It's a precise architecture where the relationship between the words matters just as much as the words themselves. And this right here essentially illustrates the crime scene. In a standard test, models like Clip were shown a photo of a jungle with absolutely no mountains in sight. But when asked to match the image to a caption, they actually gave a higher similarity score to a false distractor caption, like jungle without a mountain, than to a caption that just truthfully described the scene. They see the word mountain, they look at the jungle, and they just get terribly confused.
You see, the root of this whole problem lies in the training data. Standard AI is trained on hundreds of millions of image-text pairs scraped straight off the internet. But out there in the real world, negative sentences are incredibly underrepresented. People usually caption what is in a photo, not what isn't. And because of this, the AI simply never learned the linguistic power of rejection. It literally doesn't know how to say no.
So the really crucial point today is how the researchers behind this paper actually solved this. They decided they had to explicitly teach the AI how to say no. And to pull this off, they built a massive, highly specialized training ground called the CCNEG dataset. They went ahead and generated an impressive 228,246 image caption triplets. Instead of just handing the AI a picture and a correct caption like usual, they provided the AI with high-quality, grammatically fluent, negated captions. These served as perfect training traps. Essentially, they created a massive library of really tricky false statements to force the AI to finally pay attention.
Now, for the methodology, let's see how they actually built this. To make these traps convincing, they couldn't just throw the word not randomly into sentences. So they used a large language model to meticulously break down positive sentences into subjects, objects, and predicates. Then, they selectively flipped a single concept to create a highly realistic distractor. For example, let's take the sentence, "A person on skis makes her way through the snow." The system elegantly breaks this down, pinpoints the action, and transforms it into a perfectly fluent negative prompt. A person on skis does not make her way through the snow. It sounds totally natural, right? Which is exactly why it makes such a fantastic test for these models.
To actually utilize all this awesome new data, the researchers created a modified model called ConClip, which is short for contrastive with negations clip. They changed the standard training algorithm from a simple keyword matcher into what is basically a magnetic system. So instead of just pulling matching images and text together, ConClip actively repels incorrect distractors. They achieved this by adjusting something called the contrastive loss function across 3 distinct similarity matrices. In plain English, they forced the AI into a strict training regime where it was penalized heavily if it didn't explicitly push away negated texts and distractor images. It was finally forced to disentangle the visual semantics, meaning if the text says no dog, the math behind the scenes literally shoves dog images away.
All right, let's jump to the next section. Putting it to the test, ConClip versus the world.
we're going to see what happens when we apply this new magnetic training against existing powerhouse models. The results, honestly, they are absolutely staggering. When faced with these tricky negative captions, standard models like Clip, NegClip, and Flava were stumbling around 58 to 65% accuracy. That's basically guessing just slightly better than a coin flip. ConClip, on the other hand, achieved a near-perfect 99.7%. It clearly learned the lesson beautifully. But look, this wasn't just a parlor trick for negative words. The researchers wanted to know if this made the AI generally smarter overall. And it totally did. Core and Clip actually improved standard zero-shot image classification across 8 different datasets, jumping nearly 11% on the complex CIFAR 100 dataset alone. Turns out, by learning the concept of no, it actually became vastly better at recognizing exactly what things are. And it gets better. It outperformed standard Clip by an average of 4.4% on the totally unbiased sugar creep benchmark. Now, this is a massive deal because sugar creep tests for things like replacing, adding, and swapping objects and attributes. It's a test of pure, rigorous reading comprehension for AI. This leads us to a really surprising and brilliant finding of this paper: emergent compositional understanding. By simply teaching the AI to understand negations, it organically became so much better at parsing all complex visual relationships. It finally stopped acting like a silly bag of words search engine and started actually understanding the true grammar of the scene. Moving right along to our next section: real-world impact, better reasoning, and fewer hallucinations. Let's look at why this actually matters for you and me. Why should we care? Because by adopting ConClip's framework, the tools we rely on every day will get dramatically better. Future image generators will finally stop drawing tires when you specifically ask for no tires. AI reasoning systems used in fields like medicine or autonomous driving will become vastly safer and far more accurate. And incredibly, foundational models can achieve these massive leaps in intelligence without requiring the billions of dollars in new computing power normally needed to train them. Now, to be totally fair about limitations, the researchers did point out a slight complexity drop-off. As prompts get extremely dense, we're talking up to 5 different predicate-object pairs, kind of like a massive run-on sentence, the AI's performance still experiences a slight dip. It gets confused by the sheer volume of grammar, which makes sense. It's much like a human would struggle if you threw too many negatives at them in one rapid-fire sentence.
And that brings us to the case for teaching AI no, as we wrap up our investigation today.
The key takeaways here are crystal clear. Standard vision language models fundamentally fail at negations because they suffer from that bag of words flaw. But by utilizing the highly fluent distractors generated in the CC-neg dataset, the new ConClip framework uses contrast of loss to actively repel those errors. And the most beautiful part of it all? Learning the concept of no doesn't just fix negative prompts, it massively boosts overall AI comprehension across the board. It leaves us with a truly fascinating thought to ponder as we close out. If simply teaching a machine how to say no, which is a concept human toddlers master almost immediately, right? If that unlocks this much hidden intelligence and structure, what other basic fundamental human concepts are our multi-billion-dollar AI models completely blind to? Definitely think about that the next time an AI gives you exactly what you didn't ask for. Thanks for joining me on this explainer. I hope you found it as mind-expanding as I did.